Okay, so this is a video to help people find the antiderivatives to things that are kind of a little bit complicated. All right, so this, you can't do the power rule on any particular part of this because there's this division. So we need to get the division gone. So let's factor the denominator. It looks like there's an x in both. So if I pull it out, I get this. Oh, well, this would cancel this, and so this is just 1 over x. And what do I take the derivative of to get this? Well, that would be just L and x in absolute value plus c. This, 5 minus pi, that's just a number. That can pull out, and it'd be times 1 over the square root of 1 minus x squared. And if you look at your note card, you should see that that is the derivative of arcsine is this. So this is 5 minus pi, that number, times arcsine of x plus c. This cube root, so that's 4, this is in the denominator, cube root's 1/3 power, so if I move it in the numerator, it becomes x to the negative 1/3. And so if I use the power rule on that, which means raise the power by 1, so minus 1/3 plus 1, or 3/3, is positive 2/3. So it's going to be 4x to the positive 2/3 divided by 2/3, or you can multiply by 3/2. That would be this part, plus secant times tangent, a product normally you can't do, but that happens to be what the derivative of secant is. In your notes, it says that that is secant x. Take the derivative of that, you get this. And this term is a power rule, so we raise the 2 to a 3 and divide by 3, so the 3's are going to cancel. So it's going to be minus x to the 3rd plus c. Sine of x. The derivative of what is sine? Well, the derivative of sine is cosine, but the derivative of cosine is negative sine, so we'd have to do negative cosine x, because the derivative of cosine is negative sine, and then we'd have to do the negative of that to make it sine. And cosecant squared happens to be, according to your notes, is the negative of the cotangent's derivative. Cotangent's derivative is negative cosecant squared. That's positive cosecant squared, so it's the negative of the cotangent squared, plus c. We've got division, can't have it. This square root is x to the 1/2. This is x to the 1/2 in the denominator. If I can either think of dividing this into each of these, which means I would subtract the powers, or I can bring this up and call it x to the minus 1/2 and distribute it times each one of them, and so then I'd add the minus 1/2 to each of the powers. This is x to the 1. Subtracting a half from 1 is a half, or 1 plus a negative half is x to the 1/2. I haven't done the antiderivative yet, I'm just working this out. This is x to the 1/2 plus a negative 1/2, or square root of x into square root of x is just 1. And then 1/2 from 2, negative 1/2 added to 2, or 1/2 from 2, this is going to be plus 5x to a half off of 2 is 1.5, or 3/2. So this is what I have to find the antiderivative of. So I increase the power on this by 1. So 1/2 increased by 1 is 1.5, or x to the 3 halves divided by 3 halves, or times 2/3. And the antiderivative of -1 is -1x. And the antiderivative of this is going to be 5. Add 1 to 3 halves is 5 halves divided by 5 halves, or times 2/5. So the 5s would actually cancel, but I don't need to do this. That and plus c. This is a simple power rule. Raise the power from 2 to 3, so it's, and divide by 3, so it's just x to the 3rd. If I took the derivative, it's 3x to 1 less x squared. So that's that. This is x to the 1/3. So if I raise the power by 1, it goes to 4/3. And I'd have to divide by that new power, 4/3, or multiply by 3/4, and it's minus. And the derivative of sine is cosine, so this has got to be plus 5 sine of x, because the derivative of that would be cosine, would be this, plus c. This is x to the 1/2 in the denominator. So I can subtract the half from the powers, or I can move this up and take it times x to the -1/2. And then when we multiply, we add the powers. So 2 plus a -1/2 is the same as subtracting a half. It's x to the 1 1/2, or 3 halves. And this times this is -7x to the -1/2. So that's what this is equal to. So now to do the antiderivative, the integral of this, add 1 power to this, and that would be x to the 5 halves divided by 5 halves minus 7, increase that by 1 to be x to the 1/2 divided by 1/2, or multiply by 2 over 1, which would be 14 square root of x, plus c. I can move x to the 2 up, but the 3 is in the denominator. It's not to the 2, and it's 5. So this is 5/3 x to the -2. Power rule says increase the power by 1. So this is going to be 5/3 x to the -1 divided by -1. Now if you plus c, you could simplify that. The minus could go in front, and x to the -1 is 1 over x. This one, if it was 1 over this, it looks like something on your card. So, but we can think of this as 7 times 1 over x squared plus 1. Because 7 over 1, 7 would be multiply and make that, and the 1 would make that. So the antiderivative, we don't have to do the 7 because it's a constant. It's just 7 times whatever the antiderivative of that is, and that's arc tangent x plus c. Antiderivative of sine, negative cosine x. Antiderivative of cosecant squared x, that's negative cosecant squared is the derivative of cotangent, so this is negative cotangent x, because that would make the negative of cosecant squared, negative cosecant squared x, so it becomes that, plus c. This is ready for power rule. Increase the power by 1, divided by 5. This is x to the -1/2 it's 1/2 here, move it to the top, it changes that sign. So I increase the power by 1, it becomes x to the 1/2 times this -3, and divide by the power I got. So that's that. And I've got -3, and secant squared, according to your card, is the derivative of tangent, x plus c. Let's continue. Got division. Can't do division. Can't do them in separate pieces. So hopefully this factors to something where I can get rid of this x minus 2. X plus 2, x minus 2, they cancel. So all this is equal to x plus 2 except that 2. So the antiderivative of this, just raise the power by 1, it becomes x squared over 2 plus 2x plus c. We've got addition in the denominator. No way to split that up. So hopefully we can factor something out of this to make it look like something on our note card. Well, we can pull the 4 out, and we can pull a 3 out, and it would be times 1 over x squared plus 1. And that looks like arctangent. So this is equal to that, and when we do the antiderivative, we get 4/3 arctangent x. We've got addition or subtraction in the numerator. We can divide this into each part. So we subtract the exponents. So this is 4x minus x 5x to the minus 2, or we can think of putting this up as x to the minus 2 times this. When we multiply, we add the power, so we get 3 minus 2, which is 1, and 5 times this is that. So now when we do the antiderivative, we get raise the power by 1 and divide by the new power. That could reduce to 2. X squared minus raise the power by 1. That'd be x to the minus 1 divided by minus 1. And you could change this to plus, and you could put the x down below. So you could call this 2x squared plus 5 over x plus c. That might look better to you, but that's also correct. Ooh, and I did that one off the screen. I apologize. This one, derivative of sine is cosine, so the antiderivative of this is just 4 sine x. Cosecant times cotangent is the derivative of the negative of the derivative of cosecant, according to your note card. This one, didn't I just do this one? Let me take a look. Is this a repeat? Yep, that's the same as this one, so I've done this one. Is this a repeat? Yep, that's that one. Oh my goodness. And that's a repeat. And that's a repeat. Oh my goodness. Oop, this is not a repeat of that. It's a repeat from someplace else. No, I don't see it. So some of these are repeats. Apologize for that. I was just pulling them off of old tests. So the derivative of what is sine? Well, the derivative of negative cosine is sine. So this is -4 cosine x. And the antiderivative of this is the derivative of, well, the negative of this would be the derivative of cosecant. So it's the derivative of negative cosecant x plus c. And that takes care of that worksheet.